From land to sea, climate change affects everyone, including fish and their habitats. Coldwater species like trout and salmon are particularly vulnerable to the effects of a warming climate. Hi, I'm Seth Wenger, Associate Professor of Ecology at the University of Georgia. I led the team that developed an approach called Multiple Population Viability Analysis, which combines fish population estimates, crowdsourced species distribution information, and NASA satellite data sets to project coldwater fish populations into the future. The analysis uses high-resolution stream data and satellite imagery to estimate abundance and other population characteristics of species like cutthroat trout and bull trout. The remote sensing data from satellites like Landsat and MODIS, along with other NASA products like NLDAS-2, were essential for allowing us to forecast the extinction risk of trout populations under future climate conditions across large regions.
Trout Unlimited and partners used the tool to model information about Lahontan cutthroat trout and their habitat. This tool relies on satellite data characterizing habitat quality, other models of flow and temperature, and field collections of fish to estimate the dynamics of populations over time. When combined with other information, including genetic status, model outputs are showing where cutthroat trout could be resilient under climate change or with certain restoration activities. 5 years after the project was completed, they are guiding where federal agencies are investing resources into actions like removing non-native trout, managing populations to improve genetic health, or reconnecting streams.
We, at the U.S. Fish and Wildlife Service, use this tool to help direct investments in regional and local trout conservation efforts. In addition, we often use this tool during the consultation process to better determine impacts of new federal activities on existing trout populations. The USGS and the U.S. Fish and Wildlife Service, in collaboration with many of our partners, are currently incorporating this tool into the Conservation Efforts Database module for cutthroat trout. Since that Conservation Efforts Database captures any and all conservation actions related to Lahontan cutthroat trout and the habitats it depends on, it can then be used to inform and support management decisions. Soon, we intend to incorporate all this information into USGS's Resist, Accept, Direct triad to prioritize future trout conservation actions with climate change taken into account.
MPVA has proven to be a valuable tool for supporting conservation of cutthroat trout and other vulnerable fish species. With active collaboration with its end users, including government agencies and nonprofits, it demonstrates how science can be effectively translated into on-the-ground applications.